Hey guys, this is my first attempt to try to do something like this, so we will see how it goes. Today we're going to kind of talk about graphing motion and some problems. So the first thing I want to say is just that whenever you do any of the physics problems that we're going to be doing for the foreseeable future here, I want you to do three things. The first thing I want you to do is write the equation that you're going to use. Then I want you to plug the numbers in, and then I want you to solve. That way, when I look at your work, I can see where you've gone wrong. So let's just take a speed problem. So we will say that a car travels 1,000 meters, and I'm really bad at writing with this. I probably should have picked something that had less. This is not a touch screen. This is me trying to write with the mouse. So 1,000 meters. And the time is 4 seconds. And if we were going to calculate the velocity here, what you would need to do is you would have to use the velocity equation. V equals d over t. And then so notice I write out the equation, and then I'm going to plug the numbers in. V equals 1,000 hopefully nobody asked me to slow down, meters over, sorry, that's a bad line, 4 seconds. So that's step 1 and 2. And then you would just do the division, and your answer would be V equals, you guys can probably do this in a calculator before I can write it, 250 meters per second. So I just wanted to show you exactly how I wanted you to do the work. So that's basically what I'm looking for when we're doing any of the physics problems. This is what I want to see, only hopefully it's neater and stuff like that. So that's that. Then let's see, I'm going to get rid of this. The other part that I wanted to go over with you today will be better on this whiteboard. The other part is just what graphing motion looks like. So if we have axes that look like that, and we'll say that this is distance and this is time. What this line looks like is important. So we'll say you just have a line that looks like that. And we're going to say that that's like a straight line. And there are certain things that you can get from that. So this basically means that as time increases, so as we go along this way on the time axis, the distance is increasing. And if this is a perfectly straight line, it means it's increasing the same as we go on. Now, we'll say, let's see, where are my tools here? We'll say we take this and we have this other line, this black line. which one of those is going faster? Well, if we take a look at this, if you take a look at any point where you have the same time, this black line has gone a greater distance in the same amount of time. So that means the black line has gone faster. So what that means is that the slope of this line, and I know you guys in math have done, graphing y equals mx plus b, right? The slope-intercept form of a line, that m is the slope. Well, the higher that slope is, okay, the steeper this line will be. So this line, the slope of this line tells us what the m will be. And that is velocity. So yeah, the higher the slope, the higher the velocity. The lower the slope, the lower the velocity. So that's pretty easy. So now let's say we'll give you another axis here, and same thing, distance over time. We'll say you have, I don't know what just happened there. We'll say you have a line here, and then it flattens out. We'll say that's totally flat, and then it goes like that. So you kind of have three segments of this line. You have this part here, then you have this part, and then you have this part over here. And you have three different things that are happening there. If this is distance, and this is time, well, what can we get from this? Well, a couple things. This flat segment here tells us that as time is increasing, distance is not increasing at all. So that means it's staying still. So if the distance isn't going up, then you're basically standing still on a distance versus time graph. This first section, that line's pretty steep. So that means that the velocity there is relatively high, and especially if you compare it to this part right here. Here, you do have some velocity. You are moving, but the slope here is lower than the slope here. Okay, so that tells us that this velocity is lower than that velocity. So there are some different things that we can get from these graphs. We'll draw another one. So if this is, once again, distance versus time, and you have something that goes like this and something that goes like that, what can we say here? Well, started off with a positive slope, and then here we have a negative slope. So if this is distance versus time again, that means that for some amount of time, the velocity here was positive, and then this basically looks like it's about the same slope, only negative. So this would be a positive velocity and then a negative velocity. So that means it's going back to where it started from. If we kind of ignore the point where I went past the line here and just stop right here, that would be it, that this object went somewhere and then came back right to where it started from, because the distance where it crosses this line is 0. So just to give you some idea, it's really important that we know what different lines mean and what different graphs of motion mean. So this is in the book in 11.2. It deals with average speed and instantaneous speed and graphing motion. So let me just say a quick word about the difference between average speed and instantaneous speed. Instantaneous speed is basically what your speedometer gives you. It's the speed that you're going at one instant, at one moment in time. Average speed you have to calculate over a longer period of time. And that's like the problem that we did in the beginning, was dealing with average speed. It's how far did you go in how much time, do the division, and that's that. So the speedometer measures instantaneous speed. You have to calculate for average speed. The rest of this section of the book, 11.2, deals with velocity. So we'll talk more about velocity maybe next class. I'm going to give you a few problems for today, I think, and then we'll get into how we can combine velocities and things like that. All right. Have a great day.